Okay, so the math dealer here, and today I'm going to show you how to find the derivative of an inverse trig function. Okay, so basically the question would be, find dy dx if y is equal to the inverse sine of u. And of course, u is a function in terms of x, so I don't want you to freak out about that. All right, so for starters, you might have to think to yourself, okay, what does it mean to be an inverse sine? Like, what does that even mean to you, okay? Well, think about this. And way back in the day, the pre-cal days, that is, if I asked you the inverse sine of, let's say, 1/2, you said to yourself, hey, the sine of what angle gives me 1/2? Like, that was their question. That was a question that was asked. So then you broke out that unit circle and you were like, okay, whose sine is 1/2? Well, pi over 6, which is also my 30-degree angle, right, is the one that gives me the sine to be 1/2. So I'm hoping that you do remember that, okay? So that's a little note here, right? We're going to a little note to self. So we are going to be using this idea of like the rewrite, okay? So we're going to have to rewrite this function, right? So I have to say, okay, well, let me just rewrite it in terms like we did over here. The sine of some angle known as y is going to equal u, okay? So we're thinking to ourselves, okay, there's some angle whose sine is u. Okay, there's some angle whose sine is u. Okay, so my angle I'm going to call y, and there's some angle whose sine is u. Remember, sine is opposite over hypotenuse, so I'm going to have to put u over 1. And then that's going to give me my missing side to be 1 minus u squared by that very cool guy called Pythagoras. Alrighty, so when I'm sitting here doing this, I'm like, okay, so I got my little triangle, because you know it's a right triangle. You've seen pictures. Okay, so now let's go back to our calculus world. Come back over here. All right, and I'm going to say, all right, let me find the derivative of sine y equals u. Well, we can do that, right? Derivative of sine is cosine, right, of y. Don't change the argument. If you watch any of my other videos, you know that. But I also have to find the derivative of y, which, oh, by the way, is dy dx. And that's going to equal the derivative of u, which is du dx. Because remember, like I said, my u is some function in terms of x, hence the reason we're finding dy dx. Okay, so here we go. Let's speed this up a little bit. So dy dx is going to equal 1 over the cosine of y times du dx. Fair enough? All right, cool. Now, just of note, please, please, please don't freak out, okay? All I've done here is I used implicit differentiation when I found my derivative, okay? And then also, please also take note that when you divide by a cosine or divide by anything, you really are multiplying by its reciprocal. I know you remember that from your 4th grade math days. Okay, so now here we go. Look at your triangle. Determine what the cosine of y is based on this triangle that we came up with. Remember, that triangle that came up with from that statement. So when I say, okay, well, wait a minute, cosine of y is adjacent over hypotenuse. Well, the adjacent term is the square root of 1 minus x squared. So that means that dy dx is going to equal 1 over the square root of 1 minus u squared. Don't forget, we still have du dx. Now, if you were in one of my calc classes, sometimes I show you the form of u prime. Just remember, u prime and du dx are the same statements. So instead of saying du dx, I could say u prime over the square root of 1 minus u squared. And hence, that is the derivative, right? That is dy dx of, sorry about that, inverse sine of u. And that's not a negative. Please don't think that's a negative. Cool. So you might be saying, okay, well, how does this even work? Well, the way this works is that now, if you are given a function, for example, you're asked to find, let's say y is equal to the arcsine or inverse sine of, let's say, 3x squared. All right, that means y prime dy dx is u prime. Remember, this is my u. 6x is u prime over the square root of 1 minus u squared. And 3x squared, of course, is going to be 1 minus 9x to the fourth. And that's what dy dx equals. Okay, now the proof of that, all right, I can just walk right through what I just did. So if you actually are like, okay, well, how would I do that with the triangle method? Okay, well, the triangle method would be as such. Ready? I would say the sine of y equals 3x squared. So for starters, I did a rewrite. Okay, then draw the triangle using that rewrite. Okay, so that means this is my y. Okay, 3x squared is my opposite. The hypotenuse is 1 because it's opposite over hypotenuse, which ends up making this 1 minus 3x squared squared, which of course is 9x to the fourth. Sorry about that. Okay, now here we go. Derivative of sine is cosine dy dx, and that's going to equal the derivative of 3x squared, which, oh, by the way, is 6x. So that makes dy dx equal to 6x over the cosine of y. Now again, use your triangle to figure out what the cosine of y is. So that's going to give me 6x over, well, cosine is sitting there, it's adjacent over hypotenuse. And it's going to give me 1 minus 9x to the fourth. Hence, we got the same answer as plugging it into the formula. All right, so I hope this is a little bit helps clear up some questions that you might have on how to use the triangle to find the inverse trig derivatives. Or better yet, it's just a little bit of adding to your knowledge. All right, it's the Math Dealer signing out.